Hi guys, today we are going to be solving radical equations. We are going to look at the case where we only have one radical expression. So let's do this. So remember, what is a radical equation? A radical equation is an equation that contains a variable in the radicand. So for the first three equations, for every radical, there's a variable inside it. So we have a radical equation. The third equation, although there is a radical, it's not really a radical equation because there's no variable inside the radical. In this case, namely the square root. So it's not a radical equation. This is just a degree 1 equation or a linear equation. So if we were going to solve it, we would old school it. We subtract square root of 3 from both sides and we're good. So let's go ahead and look at our first fun problem. I forgot to write it in advance, so give me a sec. So we are asked to solve it, if my memory serves me correct. Well, there's an equal sign, so I guess we solve it. But we are asked to use our calculator to quickly check our proposed solutions, and I'll touch base in a bit why is that the case. You don't have to show the checking on the paper unless you really want to, but you know, I'm gonna do it anyways. Okay, so the question is, how do we solve a radical equation that contains only one radical? Your first goal is to isolate the squared part. So if you're not with the squared, your first goal is to isolate the radical. If you're not with the radical, you gotta go. So to undo the plus 3, let's go ahead and do minus 3 from both sides. And that will give us square root of 2x plus 1 is equal to -1. Fantastic. Work your magic. So now at this point, now that we've isolated the radical, our next goal is to raise both sides. Our next goal is to use the power rule to raise both sides to some power to undo the radical. So with your permission, we're going to highlight the index. So index is 2, hence square root. So to undo the square root, we're going to raise both sides, you guessed it, to the second power. Now the question is, what if it was a cube root? If it was a cube root, then we will raise both sides to the third power and fourth power, or fifth power, sixth power, etc. Okay, all right, I said too many words. So on the left side, the square and the square root undo each other, and that will leave us with the radicand of 2x plus 1 equals +1, because the square of -1 equals 1. So we totally nailed it. Let's go ahead and isolate the variable term. So now we went from a radical equation to a degree 1 equation or linear equation. So let's old school it. Let's go ahead, isolate the variable term. When we subtract 1 from both sides, that will leave us with 2x is equal to 0. To get rid of the times 2, let's go ahead, divide both sides by 2, and that will give us 0. Under normal circumstances, when I solve a radical equation, I always say I checked it at my house as a joke, you know, because pretty much I trust my arithmetic. But when it comes to radical equations, checking is not optional. We have to check our answer to eliminate any extraneous solutions. What is that? Let me go ahead and check it, and then I'll touch base on that. Okay, so we're gonna check it. Okay, so let's do this. So the equation, we always check it against the original equation. We have square root of 2x plus 1 plus 3 equals 2. And then as for me, whenever I'm gonna plug in something, I like to put a semicolon, and then to the right of it, I'll write down what I'm gonna plug in, or in this case, what am I checking. You can use a calculator, but I'm gonna freehand it just so we have a paper trail. So let's see if our proposed solution is actually a solution. So we have square root of 2 times x, 2 times our answer, namely 0, sorry, plus 1. When we increase it by 3, does that really give us 2? It has to be, because it's our answer, so it needs to be right. Product of 2 and 0 is 0, and that will leave us with square root of 1 plus 3. Square root of 1 is 1. And unfortunately, the sum of 1 and 3 is not 2. So this is enough checking for me if you choose to handwrite it. But again, it says you don't have to show your checking on paper. Just as long as you check it, you know, with your calculator, you're good. If you want to finish it off, though, then you have 4 equals 2. So the question is, did it check out? No. Under normal circumstances, I would be like, oh man, I made a mistake. But we have to have faith in our algebra. We did it. Now, the reason why I said when it comes to solving radical equations, checking is not optional. It's because we are prone to having extraneous solutions. An extraneous solution is a solution of one of the new equations, but not of the original equation. So in this case, 0 is a solution of this new equation, 2x plus 1 equals 1. So in this case, 0 is an extraneous solution. You don't have to write this for credit. I just do it for note-taking purposes. I don't want to say that it's wrong. It's just an extra, well, I shouldn't say extra. It's just an extraneous solution, meaning it's a solution of one of the new equations, but not of the original equation. So what are we to do? Oh, and before I forget, why is it that we're prone to extraneous solutions? Well, that's because of this. When we squared both sides, we have 4 properties of equality. We have the addition, subtraction, multiplication, and division. The one for addition, it says adding the same number to both sides, it's not gonna like change the solution, something like that. But we don't have a squaring property of equality. So because we have to use something that's not one of our properties of equality, this is why we may have extraneous solutions. Okay, I made this longer than necessary. Okay, next time remind me just to go straight to the math. So what's the answer then? So we had one possible answer. That answer couldn't fly. Let me cross it off for dramatic effect. We had one possible answer. That answer couldn't fly. Since we have nothing else to go by, then there's no answer, but we say there's no solution. So the moral of the story is that there's no solution. Okay, so that's it. For the remaining problems, we are gonna continue to do the same thing, solve it using the same strategy, but our checking, we will use our calculator to check it. Okay, cool. All right, problem B. Let's go ahead, knock it out. Problem B, we have 13 plus the square root of this beauty, x squared plus 3x minus 9, and that equals x plus 7. Fantastic. So the first thing I'm going to ask myself, how many radicals do we have? This video we focus only on radical equations that have one radical, but I'm going to pretend like I'm surprised each time. Okay, so we have a radical equation. So first question we ask ourselves is this: how many radicals do we have? In this case, we only have one radical. So according to the procedure, we are going to isolate that one radical that we're going to see. To undo this 13 that's being added to our radical, let's go ahead, subtract it from both sides. So we'll do minus 13 minus 13, and that will leave us with the square root of x squared plus 3x minus 9 is equal to x, I think 6. Let me use my fingers. Yeah. All right, so now we satisfied our first goal, which is isolating the square root, isolating the radical. Our next goal is to undo the radical by raising both sides to some power equal to the index. So because we have a square root, then the index is 2. To undo the second root, we're going to raise both sides to the second power. So on the left side, the square and the square root undo each other, and that will leave us with the radicand of x squared plus 3x minus 9 is equal to 0. On the right side, you are gonna square the binomial of x minus 6 however you can. If you are familiar with the multiplication shortcut, squaring a binomial, then you go straight to answer. So this will give you x squared minus 12x plus 36. But if you're like, I have no time for multiplication shortcuts, then let's just go ahead, FOIL it out. Okay, let's rewrite it without the exponent of 2, and we'll get the same answer. Will it take us longer? No. Okay, whatever allows you to write continuously, that is your fast technique. Okay, so let's go ahead, bring down the left side. So we have x squared plus 3x minus 9 is equal to, product of the first terms gives us x squared, product of the outer terms negative 6x, product of the inner terms also negative 6x, and product of the last term gives us 36. Fantastic. So let's go ahead, continue to work our magic and simplify the right side. So the left side was already perfect because excuse me, there's nothing to simplify. Cool. So on the right side, when we combine those middle terms or those x terms, that will give us negative 12x, and we bring down the rest of the problem. Okay, so we went from a radical equation to this kind of equation. The biggest exponent on any of the variable terms is 2, so we have a quadratic equation. We have different ways to solve it. We can solve it by factoring, maybe square root method, not for this problem. We can also solve it by completing the square. We can also solve it by using the quadratic formula. Sorry, we had a little technical difficulty here at home. So where was I? So we had a radical equation and we went to this kind of equation. The biggest exponent on any of the variable terms is 2, so we have a quadratic equation, and then we have different ways to go about it. For me, factoring is my go-to, so let's go ahead and do that. So in order for us to solve by factoring, we have to set the equation equal to 0. So let's go ahead and move one of these squared terms. So it doesn't matter which one, it's the same one. Okay, so whether you say I'll move the one on the left or the one on the right, we're both gonna move. We're both gonna subtract x squared. No one will ever know. Okay, so let's take our time, work our magic to set the equation equal to 0, so then we can follow the factoring process. So that will leave us with 3x minus 9 equals negative 12x plus 36. Okay, what's going on? We went from a radical equation to a quadratic equation, now to a degree 1 equation or linear equation. So how fun is that? So now, since we have variable terms on both sides, we need to fix it so we have variable terms only on one side. If I can read your mind, let's go ahead add 12x to both sides, so that way we can have positive coefficients. When we add 12x to both sides, that will give us 15x minus 9 is equal to 36. We keep our cool to isolate the variable term to undo the subtraction by 9. Let's go ahead add 9 to both sides. I'm running out of space. And that will leave us with 15x is equal to 45 or 45, how normal people speak. Okay, we keep our cool to get rid of the times to get rid of the times 15. Let's go ahead divide both sides by 15, and that will give us a solution of 3. So again, I'm pretty confident in my algebra. If I made a mistake, I know that you guys have my back and you will tell me. But when it comes to solving radical equations, checking is no longer optional. Okay, so we have to check it to eliminate extraneous solutions, and you can check it by hand, but I want to show you how you can use your calculator to check it. Okay, so we're gonna introduce some new buttons. Okay, well, oh, maybe I forget if I've done this. So we want to store 3 for the variable x, so we're gonna punch in 3 and then the store button. Let me go ahead take out my special effect calculator. Okay, so save it as. Okay, so we want to save 3 as x. So we have this key STO and then the arrow. Okay, so go ahead click it. So that's to the left of the number 1. Okay, so we're going to take the number 3 and then store it or save it as x. You know where the x is because we've been using it for a while. Okay, cool. So then like when you push x, it should pop up 3. Why? Because we saved it as. Okay, so when we check it, let's just go ahead punch it into the left side of the equation. So let me just put a little reminder. Check. Oh, that says CK. Okay, when I check it, let's go ahead plug in the expression. Okay, so we have 13 plus the square root. We're not gonna put 3 squared. Why? Because we already saved 3 as x, so that's how we can just push x. So 13 plus x squared plus 3x minus 9, and let me get out of the radical. Okay, so when I check it, we are going to see what the left side gives us. Okay, the left side gives us 16. The right side, x plus 7. I know you can do that in your head, but I just want to keep using my calculator. So what do we have? When we plug it into the left side gives us 16. When we plug it into the right side gives us 10. So the question that I want to ask myself is this: does 16 equal 10? And the answer is no. So my natural reaction is to say, oh, I made a mistake. But oh, we have to trust you have to trust yourself. Okay, so in this case it didn't check out, which means that it's going to be an extraneous solution. So remember, an extraneous solution is a solution of one of the new equations but not of the original equation. So 3 is a solution of one of these guys without the radical, but it's not a solution of the original equation. So the question is, well, what's the answer? Well, we have one possible answer, but that answer couldn't fly. Since we have nothing else to go by, same speech, there's no solution. Now, I don't want you thinking like, oh, does every radical equation not have a solution? No, radical equations do have solutions. Lots of radical equations have solutions. But the reason why I picked this one is because I wanted to emphasize that you better check your answer or else. Okay, so I said that we were gonna do 3 problems. These are the first 2. I'm gonna owe you 1 more. Okay, so give me a sec. Problem C. Okay, so we have another radical equation, and then we are encouraged to use a calculator to check our proposed solutions. But again, if you're an overachiever, then just go ahead and do it by hand. So first things first, yes, we do have a radical equation. We have a radical and a variable inside. What we are going to ask ourselves is, how many radicals do I have? You know, 1 or more than 1. In this case, as you can see, we only have 1 radical equation. So your first goal is to isolate that radical. To undo the addition by 4, let's go ahead, subtract 4 from both sides. And that will leave us with x equals square root of 5x squared plus 9. Fantastic. So let's go ahead, work our magic. So goal 1 complete. Goal 2, use the power rule to raise both sides to some power to undo the radical. So in this case, you know, because we say the square root, then that means that the index is 2. So to undo the square root, we're going to raise both sides to the second power. Cool. Alright, so on the left side, the square of x will just give us the square of x, or x squared, how normal people speak. On the right side, the square and the square root undo each other. This is why we squared both sides versus cubing both sides, and so forth. And that will leave us with the radicand, or former radicand, of 5x squared plus 9. Fantastic. So in this case, how are we going to solve it? So you can solve by factoring, but with your permission, we're going to go ahead and use the square root method. We want to get the squared parts on one side and then the constants on the other. So I'm usually terrified of negative numbers, so I would normally move the x squared, but I'm going to face my fears, because if we move the 5x squared, then we have variables on one side and constants on the other in a heartbeat. But if you do something else, it's okay. So if we subtract 5x squared from both sides, then that will leave us with negative 4x squared is equal to 9. Work your magic. Isolate the squared part. To get rid of the times 4, let's go ahead, divide both sides by negative 4. And that will give us x squared is equal to negative 9/4. Fantastic. To get rid of the square, let's go ahead, square root. And that's because the same thing, the square and the square root undo each other, and then at this point we'll insert our plus or minus. So on the left side, the square and the square root undo each other for the same reason that they did over here. So that will leave us with x equals positive or negative, whatever the square root of negative 9/4 simplifies to. Bear in mind that because our answer is the square root of negative number, if we do have these solutions, they are going to be non-real solutions, and that's okay too. So work your magic to simplify the square root of negative 9/4. I know you can do it mentally, but I can't, and there's no shame in that. Okay, so let me go ahead, bust out a thinking area. The first thing we want to do is to make the radicand positive. So we are going to replace the square root of negative 1 with the imaginary unit I, and then we're going to multiply it by the leftover radical, which is the square root of 9/4. You can use the quotient rule for radicals, for square roots, to simplify to separate the numerator from the denominator, but I'm not going to, because we have no time for that. Let's just square root each piece one at a time. Square root of 9 gives us 3. Square root of 4 is 2. So all together, the square root of 9/4 gives us 3/2. And let me just go ahead, put the times I at the end for aesthetic reasons. So thanks to our hard work, we have that the square root of negative 9/4 simplifies to 3/2 I. So let's go ahead and do this. We have x equals plus or minus square root of, erase that. We have x equals plus or minus whatever the square root of negative 9/4 simplifies to, which is 3/2 plus or minus 3/2 I. With your permission, we're going to write it without the plus or minus. So we have x equals positive 3/2 I and negative 3/2 I. So I know we nailed it, but again, when it comes to solving radical equations, checking is not optional. We have to check our answers to eliminate the extraneous solution. So bear with me, okay? Go ahead, bring this up, and we're gonna check our proposed solution. So we have x equals 3/2 I, and then I'm gonna just say use calculator. calculator. All right, that's how you spell it. So so you have options. You can like punch in 3/2 I plus 4, enter. Does it really equal square root of 5 times square of 3/2 I plus 9, and then we increase it by 4. But we have no time for that, so let's take advantage that we know how to use our calculator. We want to store the 3/2 I for x. Okay, so we're gonna enter 3/2, you know, because someone told me there is a fraction button, but because I don't use it, it's gonna take me longer for me to find it. But if you know how to use it, go for it. And then I'm gonna put times I. So where is that I? Let's go ahead, look for it. So the I key is not a main key, it's one of the behind keys, and it's where the decimal point is. If you want to use a behind key, sorry for that, if you want to use a behind key, you're gonna have to use a second. So we're gonna do second I. Second I. So we have second I. Cool. What are we storing? Was it that? Is it just that? So yeah, x equals 3/2 I. So we have 3/2 times I, and then we're gonna say store it as x. So the storage button, that's not how you read it, but that's how I do it. So we're gonna hit it, store. So you should see an arrow, and we're gonna store it as whatever you want. Go ahead, enter x. Okay. And because the calculator doesn't give it to me as a fraction unless I ask it to, it gives it to me as a decimal, and it's okay. So we're gonna punch it in on the calculator. So we're gonna enter the expression x plus 4. Cool. And you can just put, you know, 4 plus 1.5i, but if you want to have a paper trail for your peace of mind, you then go ahead, write down the equation, and then write down what you get. Maybe I should have done that before, but I was a little nervous. Okay, so when you punch it in, you know, when you substitute a 3/2 I for the variable x, the left side gives us 4 plus 1.5i. Notice how the calculator gives us this number in a standard form of a non-real number, which is great. So I want to know if the left side equals the right side. So let's go ahead, punch it in. Remember, we still have 3/2 I stored for x. Okay, so we just need to punch in the expression. So that would be square root of 5x squared plus 9. Get out of the radical. So if your parenthesis gives, if your calculator gives you an open parenthesis, then close the radicand with the close parenthesis. If you don't, then just get out of the radical. So we have square root of 5x squared plus 9. Let's go ahead, add 4 to it, and this is our answer. So for my peace of mind, it needs to check out. So look at that. Left side gives us 4 plus 1.5i. Right side gives us right side gives us 4 plus 1.5i. We nailed it. Okay, now, just because 3/2 I is a solution, it doesn't mean that the conjugate negative 3/2 I is also a solution. So let's go ahead, check it. Okay, so you can do it by hand, but we have no time for that. So let's go ahead, store it in our calculator. So negative 3/2 times I. Again, go ahead, use the fraction button, and then we're gonna store it. So it's that STO arrow key, okay, next to the what? Store it as x. And then we're gonna enter, hit enter, and then it'll give it to us as a decimal, negative 1.5i. Cool, fantastic. So let's see what the left side gives us. So the left side, we enter x plus 4. You know what? Let me use my fake finger. Okay. So let's go ahead, enter the left side. So it's x plus 4. So we enter x plus 4. And then we hit equals, and in standard form we get 4 minus 1.5i. So this is gonna hold true only if the left side equals the right side. So I would like for them to check out. When we plug in the right side, we have square root of 5x squared plus 9. Get out of the radical and then increase it by 4. And then the right side gives us 4 plus 1.5i. With tired eyes, it kind of looks like it checks out, but as you can see, it's a lie. The left side gives us 4 minus 1.5i, and the right side does not give us 4 minus 1.5i. So unfortunately, it didn't check out. So let me go ahead, cross it out for dramatic effect, but that's in my checking area, so I'm not gonna have to cross it out elsewhere. So our checking says that 3/2 I checks out, but negative 3/2 I's didn't. Okay, in our book, it incorrectly says that both of them are a solution, but as you can see, no. So don't trust the book all the time. People write books and people are humans. Humans make mistakes. So whenever you're doing an answer, whenever you're working on a problem, if your answer doesn't match, do it again and do it for the third time. And then if you still get the same answer, talk to your instructor, and then your instructor will confirm like, yeah, you did it. There's a technical difficulty in the book. Let's write edition number 2 or whatever. Okay guys, so I said that we were gonna do 3 problems. That was our third and final problem, so we're out. Thanks.